this video, we're going to go over a few examples of calculating molality. That means we're determining how many moles per kilogram of solvent. So moles of solute per kilogram of solvent. In this first question, it says, what is the molality of a solution containing 75.3 grams of potassium chloride dissolved in 95.0 grams of water? So if you recall, we have molality is equal to moles of solute per kilogram of solvent. So that means I need moles of my solute, in this case 75.3. So, and that's grams of potassium chloride. So I'm going to take my 75.3 grams of KCl, and then I'm going to convert that using molar mass to moles. So for every 1 mole of KCl, my molar mass, I'm going to calculate that over here. Potassium is 39.10 grams per mole, and chlorine is 35.45 grams per mole. So we add those together, and we get 74.55 grams per mole. So 74.55 grams of KCl for every 1 mole of KCl. So when I do that calculation, 75.3 divided by 74.55, it gives me 1.01. So 1.01 moles of KCl. And I take that and divide it by kilograms of solvent. Well, this is in grams, so I need to convert that. So I'm going to take my 95.0 grams of H2O, and I'm going to convert that because I know that 1,000 grams are in 1 kilogram. So I'm dividing by 1,000, and I get 0.0950 kilograms of H2O. Then I take these pieces and put them into my equation. Molality is equal to 1.01 moles of KCl divided by 0.0950 kilograms of H2O. So when I do that math, I have 1.01 divided by 0.0950, and that tells me I have a 10.6 molal solution. So 10.6 molal. Our next one says how many grams of sodium chloride were used to make a 0.9 molal solution in 1 liter of H2O. So if you remember, 1 gram is equal to 1 milliliter of H2O. So therefore, if I have 1 liter, that's 1,000 times larger than a milliliter, so I have 1,000 times larger than a gram, which is kilogram. So that means this is equal to 1 kilogram of H2O. Okay, so that's my solvent. This is my concentration, so I have 0.9 molal equal to an unknown amount divided by 1 kilogram of H2O. So that means I have 1 times 0.9, which is 0.9 moles of our unknown, which is NaCl. Then I need to take that to grams. So 0.9 moles of NaCl, there we go, grams, or not on the bottom, excuse me, for every 1 mole of NaCl, I'm calculating to determine the molar mass, but that's going to be in grams of NaCl. And it wants grams of sodium chloride. So, how many grams of sodium chloride are in 1 mole? Well, sodium's molar mass, I'll do that in a different color here, NaCl. So Na's molar mass is 22.99 grams per mole, and chlorine's mass is 35.45 grams per mole. So I add those together. 5 plus 9 gives me 14, 5 plus 9, 14, 5 plus 3 is 8, and 2 plus 3 is 5. So 58.44 grams per mole. So that's going to go down here, 58.44, and that is going to tell me how many grams of sodium chloride were used to make this solution. So I've got 0.9 times 58.44. So 52.6, but in this case, I only have one significant figure here. So, or 50 grams of NaCl. Our last problem in our examples problems is, what mass of water was used as the solvent to dissolve 2.3 moles of potassium cyanide to make a 1.2 molal solution? So, molality is equal to moles of solute per kilogram of solution. Kilogram of solvent. So, 1.2 molal, or is equal to 1.2 moles per kilogram, equal to 2.3 moles over X number of kilograms of water. So, what I need to do is get X by itself, so I'm going to take both sides, multiply by X, so I get 1.2X equals, and that's, let me rewrite that, 1.2 moles per kilogram times X is equal to 2.3 moles. So what I'm going to do is I'm going to take this and I'm going to divide both sides by 1.2 moles per kilogram. And this is going to leave me with 2.3 over 1.2, 1.9, so X equals 1.9. The moles cancel here, and the kilograms are in the numerator, so 1.9 kilograms of H2O. And that is how we would solve for this problem.